So I chose those last two examples on purpose because those fit the pattern a plus b, a minus b, which simplified to just a squared minus b squared. A would be 3, b would have been root 5. See if I can get rid of that. So a 3, b root 5, a plus b, a minus b. And then in the other example, a would have been root 6, b would have been root 3. And it simplified to just a squared, which was 3 times 3, and b squared, which was root 5 times root 5, which is 5. A squared minus b squared, 9 minus 5 is 4. And the reason for those examples is we use the conjugate. The conjugate of a value of a binomial. So if you have something like 8 minus the square root of 4, its conjugate is just 8 plus the square root of 4. So the conjugate uses that factor pattern, and with radical numbers, it's useful because it's going to help us later on when we're rationalizing denominators, have denominators that don't have square roots in them anymore. Again, this complicated multiplication simplified to just the number 4. This complicated multiplication simplified to just the number 3. And when we're rationalizing denominators, that's what we're looking for. We're looking for all rational numbers in the end. Okay, so the conjugate of 7 plus 8 would just be 7 minus the square root of 8. The conjugate of 8 minus square root of 2, would 18 minus the square root of 2 would be 18 plus the square root of 2. Ooh, all right, 2. All right, so conjugates. We're going to use that to rationalize the denominator. Earlier in this chapter, we were rationalizing denominators. So if we have 8 over the square root of 3, we would rationalize that by multiplying by a fancy version of 1, root 3 over root 3. Top times the top is 8 root 3. Root 3 times root 3 is 3. And this is the rationalized fraction. Here we rationalize by multiplying by the conjugate. So 10 minus root 5 is a conjugate of 10 plus the square root of 5. So over 10 plus the square root of 5. Do that multiplication. On the top, we would have 10 times 15 is 150. And then 15 times root 5, distributing here, would give us plus 15 square root of 5. The denominator, well, make that a binomial like this. We're going to do first times the first. 10 times 10 is 100. Outer, it's going to be plus 10 root 5. And then the inner is going to be minus 10 root 5. And the last is going to be minus root 5 times root 5 is 5. Now, at some point, you might get to a spot where you recognize how to use that factor pattern and just have 10 minus 5 right from the beginning, because these do cancel to 0. So our denominator is 100 minus 5, which is 95. Our numerator is going to be 150 plus 15 root 5. That's rationalized. In my math lab, you probably would be expected to simplify this a little bit more. Everything here can be divided by 5. So we could, let's see, 150 divided by 5 would be 30. And then 15 divided by 5 would be 3. And then 95 divided by 5 would be 19. So again, I just was able to divide a 5 out of everything there. So I don't really think this looks that much simpler than 15 over 10 minus root 5. However, it is considered rationalized where we don't have a square root in the denominator. Probably the most complicated type of problem you'll see in my math lab today is going to be one like this, but the idea is the same. We're still going to multiply by the conjugate of the denominator. So that would be 8 root 3 minus 2 root 2, and then the same thing on the top. And then top times the top, bottom times the bottom. So I'll do the bottom first, since that's what's going to simplify. 8 root 3 times 8 root 3. 8 times 8 is 64. And then root 3 times root 3 is 3. And then the inside terms are going to cancel. I will write them, though, just for the heck of it. So inside term, or outer term, sorry, first would be minus 16. Root 3 times root 2 is root 6. And then the inside is going to be plus root 16, root 6. Again, those are going to cancel. And then the last 2 root 2 times negative 2 root 2. 2 times 2 is 4, but it's negative. And then root 2 times root 2 is 2. So our denominator is going to further simplify to 64 times 3. Don't have a calculator on hand. Is 192. And then minus 4 times 2 is 8. So 192 minus 8 is, what is that, 184. Okay, so our whole denominator will simplify to just the number 184. That is a little nicer looking than what we have. Then we've got to multiply the numerator. All right, so first times the first. 6 times 8 is 48. Root 2 times root 3 is root 6. That's the first times the first. Outer times the outer. So 6 times negative 2 is negative 12. Root 2 times root 2 is 2. And then inner. 5 times 8 is 40. Root 3 times root 3 is 9. And then last, 5 times negative 2 is negative 10. Root 3 times root 2 is root 6. And now we're going to look to combine some like terms and do some simplifying. 48 root 6 minus 10 root 6 is 38 root 6. Minus 12 times 2, that's minus 24. And then 40 times 9, 4 times 9 is 36. And then times 10 is 360, so plus 360. Combine like terms just a little bit more. 360 minus 24 is 336. So 336. So we've got 38 root 6 plus 336. This will probably simplify just a little bit. Everything here will divide by 2. 38, 30, 336, and 184. 38 divided by 2 is 19 root 6. Divide this by 2, 150 plus 18, so 168. And then 184 divided by 2 is going to be 92. And the only thing we'd have to check is if these things are divisible by 19. And I don't believe they are. So that would be our simplified answer. Again, it's not, well, maybe it is a little bit better looking than our original problem, which had square root symbols throughout, and this only has one square root symbol in it, but it is a rationalized denominator. All right, so that's section 10.5. I know this video might be a little bit long, but there are a couple of important concepts there that I wanted to get through.